Quartiles break the data set into 4 quarters. If you think of your data set falling along a numerical line from smallest to largest, you can break your data set in half using your second quartile. This is also known as your median. 50% of your observations will lie below, 50% above. Now let's say you want to take your lower half and break that into half. Well, this is your first quartile. And if you want to take your upper half of numbers and break those in half, this is what you would call your third quartile. So from each one, there's 25% of your observations that fall in here. And if you try and line these up with the definition, your first quartile says that there's 25% of observations that fall below it. Your second quartile, or your median, says that there's 25 plus 25, that's a total of 50% of observations smaller than it. And your third quartile says that there are 25 plus 25 plus 25, that's 75% observations smaller than your third quartile. Another way you could think of a quartile is as a percentile. So for a set of ordered observations, and the notes here didn't quite copy over, this should say x parentheses 1 up to x parentheses n. These are your ordered observations. The pth percentile is the value of x that is greater than p% of the measurements and is less than the remaining 100 minus p. To take this definition and put it into an example, let's look at Q1, which will be your 25th percentile. So for a set of ordered observations, the 25th percentile is the value of x that is greater than 25% of the measurements and less than the remaining 100 minus 25%. So we're basically saying that Q1 is a number you could plug in such that 25% are smaller and 100 minus 25 or 75% are larger. When you see percentile, basically think it's the probability of being less than a number. If you're looking at Q2, this is your 50th percentile. So it's basically like saying at Q2, it's the 50th percentile, there's a 50% chance of being smaller than Q2. To get the upper half, that's 100 minus whatever percentile number you have. 100 minus 50 is 50. So there's a 50 chance of being smaller, 50% chance of being larger. And Q3 would be your 75th percentile. The probability of being smaller than Q3 is 75%, and 100 minus 75, that's a 25% chance of being larger. So for example, there are cases of West Nile in 44 states. The mosquito-borne disease is hitting Texas the hardest. 70% of cases are in Texas, South Dakota, Mississippi, Oklahoma, Michigan, and Louisiana, listed respectively below. Cases are particularly bad this year in part because of the mild winter, early spring, and hot summer, all of which are excellent conditions for the breeding of the Culex mosquito that carries the virus. We're going to calculate the quartiles for this data set. The first thing we need to do is order our observations from smallest to largest. The next thing we're going to do is find our second quartile, or the median. You always want to start by finding the median. Here, n equals 6 is an even amount of observations, so our median formula is this. Plugging in the number 6, simplifying, 6 divided by 2 is 3. 6 divided by 2 is 3. 3 plus 1 is 4. So this says take your third ordered observation. Here's 1, 2, 3. Take your third and your fourth, which again is 113, ordered observation, and divide by 2. This gives back the median value of 113. So step 1, find the median, is complete. Step 2, break your data set up around the median. Here we averaged these two numbers. So our median fell in between these two values. And box off the data set below the median and the data set above the median. You now have a new sample size. In the lower box, there are only 3 numbers, and this is odd. And in the upper box, again, there's only 3 numbers, which is odd. You now want to get the median for the smaller box, and the median of these 3 numbers is what we call quartile 1. So using a new n of 3, odd, our first quartile still uses the median formula, but for odd amount of observations. So I'm going to plug in 3. 3 plus 1 is 4, and 4 divided by 2 is 2. This says go to your second observation. Or if you were thinking of the tick mark method, mark off a small, mark off a high, there's your middle number, that's your median for the lower half, that's your first quartile. Or second ordered observation is 95. So there's Q1. And then to get Q3, you need, again, same formula, second ordered observation, but for the upper data set. So the second order observation for the upper data set is 119. This is Q3. So we now have our 3 main quartiles. The median, which was 113, or Q2, Q1, and Q3. I'm going to summarize our findings from the previous page. We found that Q1 was 95. The median, which is also Q2, was 113. And our third quartile was 119. If we take these 3 numbers and combine them with the minimum and maximum, we get what's called the 5-number summary. So if I add in here that the maximum, the largest observation out of these 6 numbers is 1013, and the smallest observation is 73, this is my 5-number summary. The other thing that we may be interested in finding is the interquartile range. Remember this picture. We said that 25% of your observations fall into each quartile. So if I subtract Q3 and Q1, if I subtract right here, that'll give me 25 plus 25, or 50% of the data. So the central 50% will lie within this interval. For our example, if I take Q3 and subtract Q1, this will give back 24. That's our interquartile range. Another set of definitions that we'll need are the upper and lower fence. The upper fence says to take Q3 and add on 1.5 times your interquartile range. So for this data set, we'll take Q3, which was 119, and add on 1.5 times that interquartile range of 24. This gives back 155. Coming in and scanning at the data set, any number that's larger than 155 will be an outlier, which tells us that this is an outlier. Looking at the lower fence, we take Q1, which in our case was 95, and subtract 1.5 times that interquartile range of 24. This gives back 59. Any number smaller than 59 will be an outlier. Our smallest number is 73, so there's no outliers on the lower end of the data set, but there is one outlier on the upper end of the data set. Let's change our sample size to 5. Originally from Africa, West Nile virus first appeared in New York City in 1999 and has since spread across the nation. It lives in birds. Mosquitoes bite infected birds, become infected themselves, and then pass the virus along to humans when they feed on them. Our first step here again is going to be to order the data set. We'll start by finding the median. Since there's 5 observations here, the formula for the median says take n plus 1 divided by 2. Plug in 5. 5 plus 1 is 6. 6 divided by 2 is 3. So the median is your third ordered observation. Here's your first, second, third. 113 is your exact answer for the median, which is also your second quartile. Step 2 is to box off the location. Here 113 is the median. So if we box above the median and below the median, you see that there's 2 observations in each of these boxes. We're now ready to calculate the median of the lower box, which will be Q1, and the median of the upper box, which will be Q3. Knowing that our new n is 2, this is even, the formula that we'll use to find our quartiles is plug in the number 2, simplify. 2 divided by 2 is 1. 2 divided by 2 is 1, and 1 plus 1 is 2. So as you could have suspected, the formula comes back and just says take your first and your second number and average them. So your lower quartile will just be the average of 95 and 113. And this comes back as 104. Your third quartile, you'll use this exact same formula, but just average your upper 2 numbers. And this will give back that your third quartile is 566. And remember, this was your second quartile, or your median, of 113. So some other things I could ask you to do here. I could ask you, what's the 5-number summary? You'd report smallest, first quartile, median or second quartile, third quartile, and largest. This is your 5-number summary. Another thing I could ask you to calculate is your interquartile range, which would be your third quartile minus your first quartile, or in this case 566 minus 104, which is 462. I could also ask you to calculate your upper and your lower fence. Here your lower fence would be Q1 minus 1.5 times your interquartile range. And your upper fence would be Q3 plus 1.5 times your interquartile range. So the lower fence comes out to be negative 589. And the upper fence comes out to be 1259. And if I go through and identify whether or not there's outliers, there's no numbers smaller than 589, so no outliers on the lower end. And there's no numbers larger than 1259, so no outliers on the upper end. This is the works cited page for this lecture.